Hello and good day everyone. Welcome back to my YouTube channel, and this is again Sir Marcy. For today's video, I am going to discuss grade 7 mathematics, and that is all about the significant digits and scientific notation. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Okay, so let us now start our discussion. When we talk of scientific notation, it is a simple way of writing numbers that are too big or too small to be conveniently written in decimal form. It is also called standard form in Britain. The general form of scientific notation is A times 10 raised to n, where A is a non-zero digit and n is an integer exponent. Here are the steps in converting a scientific notation or a number in scientific notation. To express a number in scientific notation, write it as a product of number less than 10 but greater than or equal to 1 and an integral power of 10. Take note that if it moves from right to left, n is positive. And if it moves from left to right, then n is negative. Let us try to examine example number 1. The distance from the Sun to the nearest star Proxima Centauri is about 24.7 trillion miles. If we will write 24.7 trillion miles, it's actually a huge number. It looks like this one. And with the help of scientific notation, we can write it this way. That is first equivalent to 2.47 times 10. Then we will just count the number of the numbers from right to left. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we will just leave one non-zero digit, which is less than 10. Okay, so since we move from right to left, and that is 13, so we can write 24.7 trillion miles in scientific notation as 2.47 times 10 raised to the 13. Take note, it moved from right to left, then n is positive. Let us now examine example number 2. A single Streptococcus bacterium is about 0.00000075 meters in diameter. As you can see, a bacteria is in very small diameter. So if we will write it again, that is this one. And take note that with the help of scientific notation, we can also write it this way. First, we'll make sure that our A is a number less than 10. Okay, so that is 7.5 times 10. Then, we are going to count the number of decimal places from left to right. So that's 1, 2, 3, 4, 5, 6, 7. So there are 7, so that is why we are going to, since it moved from left to right, then that is negative. So we can write it now as 7.5 times 10 raised to negative 7. Okay? Okay, so let's have some more examples. So on the left, we have the number, and on the right, that is written in scientific notation. So suppose I would ask you to translate or to transform 19,300 in scientific notation. Alright, that is correct. So we can write it as 1.93 times 10 raised to the 4th power, since it moved from right to left. How about example number 2? If we have 0.00000012. Okay, that is correct. That is written, when written in scientific notation, that is 1.2 times 10 raised to the negative 6. Then we have this one. This is 20,000 or 20,500,000. When written in scientific notation, that is correct. That is 2.05 times 10 raised to the 7th power. Again, it moved from right to left. That is why our n is positive. And lastly, we have this one. Okay, very good. That is now written as 7.0 times 10 raised to negative 8, since we move the decimal point from left to right. That is why our n is negative. Now, how about if we're going to expand the scientific notation, or we're going to return it back to its original form? Suppose we have 2.34 times 10 raised to the 4th power. So that is equal to 23,400. If we're going to write 1.05 times 10 raised to negative 3 in expanded form, that is 0.00105. Then we have number 3, we have 6 times 10 raised to 5, that is the same as 600,000. Okay, so let's now move on with the significant digits. What is significant digits? It is also known as significant digits of precision, or simply significant figures. Digits that carry meaning contributing to its precision instead of its magnitude. Here are the rules in significant digits. All non-zero digits are significant. For example, I have here 235, therefore, it has 3 significant digits. If we have 79,216, we have here 5 significant digits. All zeros located between significant digits are significant. So, if I have here 105 and 0 is between two non-zero digits, then we have here 3 significant digits. Also, with our last example, 2005, since the zeros here are again between two non-zero digits, then the zeros here are significant. Then we have 4 significant digits. All zeros at the end of a decimal point are significant. So if we have 5.230, we have here 4 significant digits because 0 is at the end of a decimal point. Okay? Also, we have 21.30. That's also 4 significant digits. Again, using the rule in significant. Next, we have all digits of the first factor when a number is expressed in scientific notation are significant. So we have here 8.43 times 10 raised to 7. Remember that this is written in scientific notation. So it has 3 significant digits. That's 8.4 and 3. Next, we have 2.050 times 10 raised to negative 3. It has 4 significant digits. Underscored or special zeros of a whole number ending in zeros are significant. So if we have 24 or 27,000, we only have here two significant digits. If we place an underscore in its zeros, we have here four significant digits. Okay, the following digits are not significant. Zeros at the end of a whole number unless specified to be significant. For example, we have 2,000. This number contains only one significant digit. For example, number 2, we have 2040. It contains three significant digits. Zeros following the decimal point in a number between 0 and 1, like for example, we have here 0.005, it contains only one significant digit. And if we have 0.0050, this one contains two significant digits. Okay, now it's your turn. I want you to answer the following seat word and I'm going to give you only 15 seconds. And timer starts now. Alright, time's up. Let's now check your answer. For number 1, if we will write it in scientific notation, the answer is 3.8 times 10 raised to 5. For number 2, that is 7 times 10 raised to 6. Number 3, that is 3.53 times 10 raised to 11. And for number 4, that is 5.07 times 10 raised to 11. Oh, sorry, that is 8. Okay, and for number 5, that is 4.57 times 10 raised to 2. So I hope you got it correct. And for your assignment, you're going to expand letter B and also you're going to identify the number of significant digits that A and B have. Okay, so that's all for now. I hope you learned something new and I'm going to see you soon. Goodbye.